Hi, my name is Jorge Vago. I'm one of the 2 European scientists working in ExoMars for the European Space Agency. That means I'm a middleman between the engineers that are putting together the mission and the scientists that want to use it to make cool discoveries on Mars. This is a Mars globe where the colors indicate height. So blue is low and red is high. First thing you notice is that the northern part of Mars is much lower than the southern part, about 7,000 meters lower. Second thing you notice is that the northern part is smooth and therefore young, and the southern part is old and full of craters. So for our ExoMars landing site, we want to go old, at least 4 billion years in age, which means we need a place full of craters. But we also need to go to a low place, because otherwise we don't have enough atmosphere for our parachutes to work. The only area of Mars that combines the requirements of being sufficiently old and sufficiently low is around here. One of the signs of life that the ExoMars rover will be looking for are the type of signatures preserved on the surface of rocks. Here I have an example, 3.5 billion years old, from Australia. And what we see here is a piece of the bottom of a lake. The planet was young and a lot of volcanic ash was falling on the water. And we see flat layers where there was no life and the ash was being deposited. But we also see these conical layers, and these are little microbial colonies. You have to imagine this was happening over a large area at the bottom of the lake, and we had many of these little cones. Each one of them was a microbial colony. So if we find something like this on Mars, we'll be over the moon. Finding that we are not the only life in the solar system will be really interesting in itself. The second thing that we could try to do, although this may take more missions, is try to find out if there was life on Mars, if it was like our life, or if it was based on other chemical Lego bricks. So we'll see.